Okay, today we will continue with our lesson on set theory. In lesson 1, we talked about membership and cardinality. Today is lesson 2. We will talk about the roster form and the set below notation. Okay, so let us start. Okay, so we will look at the roster form. So for the roster form is basically having the members of that set listed. That's simply the roster form. So let's see example. Example number 1, the set of positive even numbers less than 15. We have 2, 4, 6, 8, 10, 12, 14. Okay, 14, because the next even number will be 16, but 16 is not part of this set because 16 is greater than 15. Okay, so this is our limit. So we have from 2 to 14. So we list these members in the roster form. So our set will just simply be set A equals 2, 4, 6, 8, 10, 12, and 14, and we enclose them into the pair of braces. So this is our set for this problem. Okay, so let's look at problem number 2. The set of natural numbers greater than 10. Okay, the set of natural numbers greater than 10. And we know natural numbers are numbers beginning from 1, 2, 3, and continuing up to infinitive. So, but we continue here for this problem, they say greater than 10. So we have 10. And the next one is 11. The next one is 12, 13, continuing all the way. So since it say greater than 10, so it means 10 is not going to be part of it. The next one is 11. So it must be from 11 going upward. All right. So the roster form will just basically be set B equals 11, 12, 13, ... So we usually use 3 of the first terms, to establish the pattern of the identical set. And afterwards, you represent the rest of the elements or the members with dots. So that indicates that it's continuity. And they clearly shows that this is an infinite set. The next one has to do with the set below notation. So for the set below notation, we say it uses a variable, usually x, and places limits or condition on a variable. So we usually use x, and there will be a condition placed on our x, and also there will be a limit placed on our x. So let's see example. Example number 1, the set of positive even numbers less than 15. So one thing we need to understand is for even numbers are numbers divisible by 2. So we have 2, 4, 6, 8, 10, 12, and 14 as the members of this set. But now to write it using the set below notation, we are not going to use x because the pattern here is that successive terms are different by 2. Okay, so instead of x, we use 2x. Now, the next thing that we need to know is the condition. The condition is that it must be a positive number. So we could say that it's a natural number, or you could say it's a whole number, or it's an integer. Okay, so all of those conditions are possible. So we use natural number. Then the limit. The limit is such that we need to know what value of x will make this statement to be true. So we take the 2 and equate it rather to the expression 2x. Okay, 2x equals 2. So 2x equals 2, the x will be 1. Okay, then we take 14. 2x equals 14. Then our x will be 7. Okay, so the limit of x must be 1 to 7 because If you have x to be 8, for example, if you have x to be 8, you have 2 times 8, which is 16. 16 is off this set. So our set will be 2x such that x is a natural number and 1 is less than or equals to x less than or equals to 7. Okay. All right. Let's look at number 2. The set of natural numbers greater than 10. Okay, set of natural numbers greater than 10. And we know those numbers are 11, 12, 13, and continuing. Okay, so the pattern is that successive terms are different by 1. So we use x, and the coefficient of that x will be 1. And the condition is that it must be a natural number. So it will be a natural number. And what's the limit? The limit is that we have the lower limit, but the upper side, there's no limit because it goes into infinitive. So we have the limit as 11 less than or equals to x and less than infinitive because it goes into infinitive. So you have b, set b is equals to x such that x is a natural number and 10 is less than x less than infinitive. So this, you could also write this as 11 less than or equals to x less than infinitive. Okay, so it could still be the same. All right. Okay, so let us look at these exercise problems. Write each of the following as a set using A, the roster form, and B, set below notation. Number 1, the set of whole numbers less than 8. Okay, and we know whole numbers are numbers beginning from 0 up to infinitive. So you have 0, 1, 2, 3, 4, 5, 6, 7. Okay, for this set, it will be definitely these members because it says less than 8, so 8 is not included. So for the roster form, you have A equals 0, 1, 2, 3, 4, 5, 6, 7. Okay, beginning from 0 and ending at 7. Okay, for the roster form. And for the set below notation form, the variable that will be used is x, and the condition that is that it must be a whole number, and the limit will be 0 less than or equals to x less than or equals to 7, or better still, you could say less than 8. All right, so we say that A equals x such that x is a whole number, 0 is less than or equals to x less than 8. All right, so let's see the next problem. Number 2, the set of natural numbers between 10 and 500 exclusive. So those natural numbers are from 11, 12, 13, 14, 15, 16, all the way to 500. Are we going to list all of that? No, the board even will be small for that. Okay, so what we usually do in such a case is we write the first 3 terms, the first 3 members of that set, because the first 3 members of that set will establish the pattern of that set. So after establishing the pattern of that set, if it is an infinite set, then it will be followed by the 3 dots only. Okay, but since this is a finite set, then you have the 3 dots followed by the last member, okay, or the limit of that identical set. So for this set, you have 11, 12, 13, followed by 3 dots, and ending up to 499 because 500 is excluded from this identical set. So our set will be B equals 11, 12, 13, the 3 dots representing all of the other members in between here and ending at 499. All right, so in the set below notation form, the variable will be x, and the condition is that it must be x must be a natural number, and the limit will be 11 less than or equals to x less than or equals to 499. Or better still, you could also use the 10 and the 500. So meaning it will be 10 is less than x less than 500. Okay, so this and this 11 less than or equals to x less than or equals to 5 or 499. Okay, it's just the same statement. All right, so we have b equals x such that x is a natural number and 11 is less than or equals to x less than or equals to 499, which is also written as x is a x such that x is a natural number, 10 is less than x less than 500. So it means the same thing. Okay, so we look at number 3. Number 3, the set of all natural perfect cubes greater than 10. Okay, perfect cubes. Okay, so we need to understand what are perfect cubes. Okay, and perfect cubes are okay, like 2 times 2 times 2 is 8. Okay, so 8 is a perfect cube. Then we also have 3 cube. Yeah, 3 cube, which is 3 times 3 times 3. That is 27. So 27 is a perfect cube. Then 4 cube, which is 4 times 4 times 4. And that will give us 64. Then we have 5 times 5 times 5. And that will give us 125. Okay, so these are perfect cubes. Now, and the problem says perfect cubes greater than 10. So this is 8. 8 is less than 10, so it's not going to be part of the set. And the first member of that set will be 27, because 27 is greater than 10. So you have 27, you got 64, then you have 125. Okay, so these are the 3 first members of that identical set. So we will use them to establish the pattern. Okay, so after establishing the pattern, and we go to the limit, but for this it doesn't have any limit because it says greater than 10. So all other perfect cubes that are greater than 10 are part of this set. So it's an infinite set. So for A will be okay, the set of 27, 68, 125, and continuing with 3 dots. So these are the first 3 perfect terms of perfect numbers that are greater than 10 and continuing to infinitive. And B, to write this in the set builder notation form. Okay, so for the set builder notation, our variable is x, but we are going to use instead x cubed because the problem is talking about a perfect cube. So the variable will be x cubed. And the condition is that the value must be a natural number. And the limit will equate x cubed to 27. All right. So we equate x cubed to 27, and then we solve for x, which is just the cube root of 27 is 3. So 3 becomes our lower limit. So if x take on the value of 3, then we will have this 27. All right. So it means our solution now will just be b equals x cubed such that x is a natural number and 3 is less than or equals to x less than infinitive. Thank you and see you in the next video.